So, as I told you guys a couple classes ago, we're not going to learn anything new for the rest of the semester. What we are going to learn is different ways of applying the stuff we already know. No imaginary numbers. So what we're going to look at today is we're going to look at a situation something like this. If I want to find the area of a triangle, we have a couple of different formulas out there for it right now. One formula is the area is equal to 1/2 base times height, right? Or base times height divided by 2. Another formula we have out there is Hero's formula. Area is equal to square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. So if we are given a triangle where we have a side that's 18 inches long and a side that's 21 inches long, and we're told this angle in between them is 54 degrees. Theoretically, we could go ahead and find this missing side over here using what? Law of cosines, because we'd have two sides and the angle in between them. That'd be law of cosines to find that third side. Then we would have all three sides and we could apply Hero's formula to get the area. Well, both of those are kind of ugly formulas. Law of cosines is a little bit long. Hero's formula is definitely a long, ugly process. So it'd be nice if there was some way that we could steer ourselves back towards this simpler area of a triangle formula. What we would need to know is an altitude, or the height of the triangle. If we use the 21 as the base of the triangle, do we have a way of finding that height? Well, yes, we do. Because we can look at this triangle. No, it will not be half of 21. No, it will not. The only way it would ever be half of 21 is if these two sides were equal. It's the only way it would ever be half of 21, but it will not be half of 21 in general. But if we look at that red triangle over there, I'm going to redraw it over here. We have, this is H, this is 18 inches. This is 54 degrees. We have a right triangle. We know another side and another angle. We can find all the other sides if we want to. But all we really need to find is H. According to the 54 degree angle here, H is which side? The opposite. The 18 is the hypotenuse, which is sine of an angle. Is opposite over hypotenuse. So we're just going to plug in sine of 54 degrees equals H over 18. And now we put this over 1 and we cross multiply and divide. 18 times the sine of 54. 14.562. We're just going to go 14.56. Is H. So now we can find the area of the triangle. The area is going to be 14.56 times 21 divided by 2. $152.90. That is inches squared. So we used our trig to find the height. But whenever we have a situation like this, where we have two sides and the angle between them, the height, this height right here, is always going to be just, here you notice it was that side times the sine of that angle. That height is always going to be that side times the sine of the angle. Make sense? That is the height. So rather than doing base times height divided by 2, we can simply do this. The area of that triangle is equal to the base, which is B, times the height, which is going to be A times the sine of C, over 2. So whenever we have two sides and the angle in between them, the area of the triangle is B times A, or A times B is usually the way I write it, times the sine of C, the angle in between them, divided by 2. So given this triangle, its area can simply be found as 57 times 42 times the sine of 31 degrees over 2. 57 times 42 times sine 31 divided by 2. 616.50. That is going to be feet squared, or square feet. What do you think? That works? I'm going to have you guys try some here. Yeah, I'll be nice. Yeah. Find the area of that one quick in your notes. Okay, so this area is going to be 38 times 24 times the sine of 59 degrees over 2. 38 times 24 times sine 59 divided by 2. 390.87 square feet. How many of you had that? Okay, beautiful. So what if I do this to you? So in this picture, let's say that this angle here is 113 degrees. This is 27 feet, and this is 25 feet. Now looking at this, you're saying that's obtuse. But will it still work? Well, let's see here. The triangle formed here is going to be this one right here. The height of this triangle is this distance. To find that distance, technically I need to use this angle here, which would be the supplement of the 113, right? That would be 67 degrees. Find the height. Do I have to do the 67 degrees though? Let's see, what's the sine of 67 degrees? 0.920504. What's the sine of 113 degrees? 0.920504. Right? Remember, if two angles are supplements, they have the same sine. That's from that unit circle. Well, this angle and this angle are supplements, they have the same sine here. So even though technically it's the supplement of this angle I should use to find the height, I can just go ahead and use that angle. So this still will apply. The area will still be 27 times 25 times the sine of 113 over 2. So 27 times 25 times the sine, 113 divided by 2. Here's 310.67 square feet. What do you think? Still better than sharp stick in the eye? So for your notes, see, that's 128 degrees. That's 54 inches, and this is 92 inches. Find its area in your notes quick. How do I do it? Perfect. 54 times 92 times sine of 128 degrees over 2. Which gives me what? 1957? Sounds legit. 1957.42. And that is, did anybody put square feet on that? Should be square inches. Not inches. I want you guys to try another one. Try to find that area. How many of you did 38 times 31 times the sine of 61 degrees divided by 2? What's the problem with that? It has to be the angle between the two sides. So we have to do a little bit of pre-work here. We can do 31 over the sine of 61 degrees equals 38 is the only other piece of information, but that's going to be this angle up here. So I'm going to label these A, B, C here. So that's going to be over the sine of angle B. So I will cross multiply and divide sine of 61 times 38 divided by 31. Sine 61, oops, times 38 divided by 31. Gives us, oh, there's a problem. This one isn't going to work, is it? Well, that was a nice little example of me to give you. It didn't work. Let me try that again. Why doesn't it work? Because if this side is 38 with a 61 degree angle, 31 is not going to be long enough to ever reach back down to it. So let's try this again. I'll try to do better. Let's say this is 62 feet and this is 59 feet. That one should work. It better. So I'm going to just go ahead and label this. A, B, C, little a, little b, little c. So we're going to start out with 59 over the sine of 54 degrees equals 62 over the sine of angle B. So we'll cross, multiply, and divide. Sine of 54 times 62 divided by 59 is 0.8502. So I'm going to go ahead and do my inverse sine to get B. (58.23 degrees). Now the way this picture is drawn kind of ambiguous because this is almost like a right angle here. I can't tell whether it's acute or obtuse. I am going to tell you right now that it's an acute angle. Okay? So it is the 58.23 degrees. Which means this one down here has to be 67.77 degrees. How does that, why does that have to be 67? Because I add these all up and subtract from 180. Now that I have the 67, now I can find the area using these two sides and the angle in between them. So the area will be 62 times 59 times the sine of 67.77 degrees over 2. Gives us 1693.06. Those are in feet, so that'll be square feet. Questions?
Are we doing this as like a tag team or just a mock? All we have to do is put in shitty structure up and go knocking.
So for this one, I'm going to give you that is 19 degrees there. I'm going to give you that this is 32 feet, and this here is 58 feet. And this is obtuse. I want you in your notes to find the area of that for me. Okay, so where do we start here? Do we have two sides and the angle in between them? No. So we have to find missing sides or missing angles. So here we have a pair. We have the 32 over the 19 degrees, over the sine of 19 degrees is going to equal, or 58 over what? Sine of, we'll call this, let's just label it A, B, C. So it's going to be sine of A. So we're going to cross multiply and divide. Then we're going to inverse sine to get the angle. So sine of 19 times 58 divided by 32 is 50.5901. Now we're going to do an inverse sine. Makes that 36.16 degrees. Now that's not what we want, is it? We want its supplement. So 180 minus that angle gives us 143.84 degrees. This one up here is going to be 17.16 degrees. Correct? How did I get that? 180. Subtract from 180. So now I can find my area. My area must be 32 times 58 times the sine. What angle do I want? 17.16 degrees over 2. Is 273.80. And that is in feet, so it's in square feet. So how would this apply to a picture that looks like this? Yes, that is a parallelogram. I give you that 62 degrees, and this is 48 feet and 64 feet. Well, if I cut it across like this triangle and this triangle are identical, aren't they? Exactly the same. Yeah. So basically, I just don't have to divide by 2. Right? So my area here will just be 64 times 48 times the sine of 62 degrees. I would divide by 2 to get the triangle, but I'd multiply by 2 because there's 2 of them. So we'll just save the trouble. So 64 times 48 times sine of 62. 2712.42. That is in square feet. What do you guys think? Doable? Okay, so I'm going to pass out a worksheet to you for homework for tomorrow. You guys will have 15 minutes to get started on it, or finish up on your test, whichever.